Okay, let's look at number 4. This is an alternating series. So I have a couple of choices. I could try first to see if it converges absolutely. Maybe I would use the ratio of the root test, but I'm going to start with just the alternating series test. So the first thing I have my, what we've been calling Bn, 1 over natural log n. Okay, if this is my An, my Bn is the absolute value of An. Think about that. The limit as n approaches infinity of my Bn is 0. That's one of the things I need to check. Okay, I also need to check that the Bn's are decreasing. So I know that for any n, natural log of n plus 1 is greater than natural log of n. This is saying whatever power I have to raise e to get n is going to be less than the power I have to raise e to get this bigger number. Okay, the natural log function is increasing. So 1 over natural log of n plus 1 will be less than 1 over natural log of n. All right, this is saying Bn plus 1 will be less than Bn. In other words, my sequence is decreasing. Okay. So putting all this together, my original series converges by the alternating series test. Is it absolutely convergent or conditionally convergent? Now I have to tell. So I look at the series of absolute values. Okay. Now, if I don't know anything about this series, I'm going to try to compare it to something. Let's compare with 1 over n. This diverges. It's the harmonic series where we talked about why it diverges. Okay. I would try to do the limit comparison. So I want that divided by that. Take the limit of that. Let's see. I'm going to replace n with x so that I can use L'Hopital's rule. Thinking of it as a function f of x that matches this sequence. Okay. Well, that's not good news as far as the limit comparison test, but what this actually tells me well, I have a fraction here, and the limit of my fraction was infinity. That tells me that the top is bigger than the bottom as long as n is big enough. So the top is bigger than the bottom when n is big. So since my series that I'm looking at, this series right here, is made up of terms which are bigger than the terms of this series, and this series diverges, k equals infinity, my series, this series, has to converge as well. Sorry, diverge. By the comparison test.